1. Earlier we recorded the derivation of the 5 linear equations in the x direction for projectile motion. Now we're going to analyze the 5 linear equations in the y direction for projectile motion. If we go back and look at those 5 linear equations, Vf is equal to Vi plus At. Distance is equal to 1/2 Vf plus Vi times time. Distance is equal to Vit plus 1/2 At squared. Distance is equal to Vit, Vft minus 1/2 At squared. And Vf squared is equal to Vi squared plus 2Ad. Now, we're going to take these equations and we're going to make substitutions for projectile motion, because the object is being launched at an angle, and as it travels, it's traveling in one component in the x direction and one component in the y direction, but gravity is slowing the object down as it travels upward in the y direction. But it's linear, so we can analyze this with the 5 linear equations. We're going to substitute g every time we see an a, but since it's traveling up, we're going to put in negative g. Final velocity is going to be equal to Vyf. Initial velocity is going to be equal to V naught y. Gravity, or acceleration rather, let's put A. Acceleration is caused by gravity, and we're going to say that it's slowing it down, so it's negative. And distance is going to be Yf minus Yi for final y minus initial y. So Vf is Vyf is equal to Vi, so it's V naught y, plus At, so it's going to be minus Gt. All right, that's equation 1 modified. Equation 2 modified. Distance is Yf minus Yi. 1/2 Vf is Vyf plus Vi is V naught y times time. The third equation is distance, so it's Yf minus Yi equals Vit. Vi is V naught y times time, and that's plus 1/2 At squared, so it's minus 1/2 Gt squared. That's the third equation. Equation 4 starts with distance, so Yf minus Yi equals Vf is Vyf times time. Now, it's minus 1/2 At squared, so it becomes plus 1/2 Gt squared. And then equation 5 is Vf squared, so it's going to be Vyf squared is equal to V naught y squared minus 2G Yf minus Yi. Now, we want to make one more substitution, because V naught y was equal to something else in our earlier derivations. If we analyze this triangle again, this is V naught here, and this was V naught x. V naught y was here, theta's there, and that's 90 degrees. Sine theta is equal to V naught y over V naught, so V naught y is equal to V naught sine theta. We want to substitute, for every time we see V naught y, we want to substitute V naught sine theta. And so we're just going to go through and box those. So it's in equation 1, it's in equation 2, it's in equation 3, it's not in equation 4, and it is in equation 5. So we're going to rewrite equations 1, 2, 3, and 5, adding in that substitution. So equation 1 becomes Vyf is equal to V naught sine theta minus Gt. Equation 2 is Yf minus Yi is equal to 1/2 Vyf plus V naught sine theta t. Equation 3 is Yf minus Yi is equal to V naught sine theta t, and that's minus 1/2 Gt squared. Equation 4 is Yf minus Yi. Equation 4 is the equation that doesn't change. And we'll just copy it down here. 1/2 gt squared. Equation 5 is vyf squared is equal to, now this is v naught y squared. So it's going to be v naught squared sine squared theta, and then minus 2g yf minus yi. And those are the 5 equations for projectile motion in the y direction.